Hi there. Good afternoon to all of you who is online. And on behalf of Taiwan Space Union, the TSU, my name is Tien-Yin. I'm from Fengjia University. This is my pleasure to invite you and also to welcome you to the sixth lecture of this afternoon. Will be 2 hours lecture, and the lecturer will be one of my colleague. His name is Lawrence Chou, and he has been a specialist in GIS Research Center in Fengjia University for many years. And he is expert in UAV application and also some of the remote sensing image analysis. So this is the GIS online program course hosted by the Taiwan Space Union. And in the previous 5 lectures, we talked about the GIS, about the smart city, about the disaster management, about some of the database like the data cube, those kind of theory and methodology and application. So this afternoon, we'll be talk about the application of the UAV images with the satellite images. And Mr. Lawrence, he's going to host for the 2 hours lecture. So you're really welcome to join this course with the Taiwan Space Union. And after the course, there will be, just like before, 2 very simple questionnaire. And also next week will be the final week for those of you who like to get a certificate from the TSU. Please also join the next week, the final course. So thank you again. So let's welcome Mr. Lawrence Chou. So, okay, Lawrence, it's your stage now.
Thank you very much, Jamie, and good afternoon, everyone. So may I know if you can listen my voice loud and clearly?
Yes, no problem.
Okay, thank you so much. Hi, good afternoon, everyone, and welcome to the course 6 of the Geographic Information System online course. Today's topic is the special application of UAV and satellite images. Just beforehand, I would like to apologize for my voice because I've just recovered. Actually, I'm still recovering from a bad flu last weekend. So my voice is still recovering. If you cannot listen to me loud and clearly, or if you have any question, please feel very free to leave a message in the chat room, or maybe raise your hand, or maybe here you can just voice out to let me know, and we are very free to discuss here. Okay, my name is Lawrence, and thank you, Jimmy, for his introduction. I'm from GIS Research Center in Fengjia University. Okay, actually, I participated as a lecturer last year. If you have joined me before, I talked about the UAV images. And here is some of my little background. I'm a UAV course lecturer in Fengjia University. I participated and enjoyed quite a few of projects with the government and also with the private sectors. I'm also the UAV operator and image analyzer. I have around 6 years of experience to handle some project with UAV. No matter the multi-rotary UAV, just like a drone that you can see very common nowadays, or some fixed wing and single rotary UAV. This is the course outline of our today's lecture. Today's lecture is going to consist of 4 parts. The part 1, and I will give some brief introduction to the remote sensing imagery. I believe in the previous 5 sections, you may have heard about how quite lots of remote sensing ideas from different lecturers. However, I will give some idea from the perspective of the UAV and also from the satellite images. For the part 2 and part 3, I will share some case studies of using remote sensing and in the environmental monitoring and also in the urban studies. Both of these 2 are very hot topic nowadays. And in the 4th part, I will show some demonstrations of building the 3D models I will talk about how to make the 2D map, 3D models, and how to make it visualized. Okay, let's come to the introduction. Many people talk about how the remote sensing. So what actually is it? For this question, I asked NASA, but in the internet, of course. So I have browsed the web. So NASA told me a lot of stuff. So how NASA concerned everything, almost everything from and above the space. So it told me about the orbits, the electromagnetic spectrum, sensors, resolution, data processing, and so on. Well, quite a few of them are related to satellite out of the space, but I have few particularly interest to the sensors and resolution. It seems very complicated, isn't it? But it gives a very good topic sentence. For the first line of the introduction, it told us that the remote sensing is the acquiring of information from a distance. From a distance is not necessarily from the space. So when you take a flight from 36,000 feet, when you look down the flight and you see, oh, very beautiful scenery, you take a picture. When you hike a high mountain, you take a picture for far distance. Or maybe even you take a car on the road and you remote sensing images. And also you can apply it to the UAV guide, and it can mainly fall into two different categories. The first one is the passive sensor, and the second one is the active sensor. For the active sensor, it is from the name, it is very obvious, saying that it can emit some signal and also receive back on the other hand. So the signal they emit is called the electromagnetic wave. So there are different types of the active sensors, namely the radio detection ranging sensors, which we call it here radar. I think many of you have heard about it before, the radar. Second one is the altimeter and also the scatterometer. So for this kind of sensors, they mainly operated in the microwave band, the band that we cannot see with a very short wavelength. So these tools are very useful for earth science research, which measure different type of earth science stuff. Let's say the some vertical profile of the aerosol, forest structure, precipitation, wind, and so on. So you can find this kind of sensors on a satellite. Let's say for the weather satellite, it is very useful. So for the second type of the sensor is a passive sensor. There is a wide range of passive sensor. Theoretically, it means that it uses the sun as a source of energy. So when the sun emits the sunlight to the earth, the object reflects the light and received by the sensors. Not only received by the satellite, and also received by different type of sensors and cameras. So they receive the light, the energy reflect from the object. There are different type of radiometers. So the most common type must be here the visible light, which means the lights that we can see, the infrared, the thermal infrared, microwave, and so on. There are so many different use of such kind of sensors, such as how to measure the land, the sea surface, the temperature, the weather properties, and also other physical attributes. But there's one thing, and that is quite a disadvantage of this kind of sensor, is that it cannot penetrate through dense cloud cover. It is a limitation and also a characteristic of such kind of sensor. So in the following lines, for the following slides, I'm going to talk about a couple of different sensors. From the left to the right, there are the visible light camera, the NDVI camera, thermal camera, and also the LiDAR sensors. So these are the major type of sensors that can be carried both in the mainly here in the UAV, and some can be found in the satellite. Okay, visible light camera. Need not to say it is a well-known sensor. You can find the visible light camera almost everywhere. You can name it just like your cell phone. You can find it in the webcam. That's why you can see me through the laptop. You can find it in the surveillance camera, the parking camera at the back of your car, and so on. It is so well-known, so useful, and cheap on the other hand. Therefore, it has the advantages that it is relatively low price, easy to obtain, and my cell phone got 3 cameras. I think some of you may have got 4, and some maybe got even more. So easily to obtain. It has a wide range of application. You can take pictures for leisure, for surveillance, for a lot of professional purposes. And you need not to have much training required for the analysis. So maybe here you have some more ideas about the application. Tell me in the chat room. However, there are also some disadvantages of such camera sensors. For example, it is heavily weather dependent. What does it mean? It means that it can be highly depends on the weather situation. If it is a rainy day, if it's a cloudy day, you can have a good picture with the visible light camera. And also, it is because you need to have the sun, you need to have the light refracting from the sun. That's why it is only limited to the daytime operation only. Okay, for the second one is called the NDVI camera. I believe some of you must have heard about this sensor before. It is a very useful tool for the modern agricultural purposes. Actually, it is a modified camera sensors. So you can find it in a lot of drums, especially to study the crops production. It can measure and quantify the health of the vegetation. How can you do that? You can see for the image here, when the drum fly over the land, it can scan the land. And for the picture that the drum received, it's no longer a visible, colorful picture. It is very colorful, of course, but the color is different. You can see some yellow, green, and red. So after some calculation, the color of this pattern can be shown in the computer. For the green pattern, it means that those plants are healthy. For the yellow part, it may mean that her crops is running out of water, or maybe because there's a road, some concrete building. It is not necessarily a plant. So by this comparison, the farmer can tell which area has a better crop and which area needs some more water or maybe fertilizers the farmers need to take care of. And so for the advantage of such sensor, the operator or the farmer, they can visualize some invisible plant health problem very quickly. So the drum scan the farmland quickly, and you can have the result. But there is some disadvantages. For example, it is high cost. The sensor itself is quite expensive, and you need to be trained in order to analyze the results of the farmland. Okay, so after the NDVI, another example is the thermal camera. It is a kind of very high-end sensor and a passive camera. So instead of the visible light, it receives the near-infrared emitting, or the temperature emitting from the object. So it can detect anything with temperature. From the minus 273 degrees onward, you have temperature. So it can the sensor can tell you which is hot and which is cold. For the picture on the left-hand side, you can see, I believe this is a solar panel. Some yellow pattern and then some with the purple, pink, some orange color. So different color represent different temperature, and you can see some dark and then some dark black, dark purple color. It may represent some cooler area. So it is very useful indeed, and because it is not sensing the visible light, therefore it can also be used at night for the search and rescue purposes, environmental survey, and many more. The advantages, as I mentioned, is that it can be used during the night operation, and you can for example, some hiker maybe he fall down from a hill, and then you need to go search for him, and you can use such kind of sensor to search him during the nighttime as well. So it can visualize some invisible temperature difference from the sensor. It is fast and also very efficient. Since this is so useful, it has some disadvantage. Many countries, just like the United States, regard such kind of thermal camera as a national security sensitive equipment. If I want to buy a high-end thermal camera, I need to get a lot of paperwork and a lot of approval. And then it doesn't necessary that I've got money and I can buy such sensor. And it is expensive, of course. There's a lot of training required in order to analyze those results and pictures. And the high-resolution thermal camera is always subject to the export restriction. Okay, so for the fourth sensor, it is called a LiDAR. So I think some of you may also heard about LiDAR as well. For the long term, for the full term of the LiDAR, it is called the light detecting and ranging. So you can see with light, with detection, and with ranging. So it is an active sensor. It means that it sends out some signal and also receiving it at the same time. It uses a pulse laser to measure the range from the sensor to the object itself. So it can receive the range information. So for each laser beam received from the object, it is a dot. We call it here the point cloud. So the sensor itself can generate a very precise 3D information about the shape of any object, and of course of the Earth's surface, and also some characteristics. So the system consists of a laser emitter, a scanner, and also a specialized GPS receiver. It is very accurate. For some application, it can fly through a mountain area to scan for some power lines. You can imagine the power line is so thin compared to other land characteristic like a tree, like some rocks. It's so thin and so tiny. But the light itself can scan the position and to map it, to graph it very precisely. So the advantage is extremely high accuracy with details. But on the other hand, it has disadvantage is that it is expensive, and expensive. In Chinese, we've got normally when we say the thing in 3 times, it means that very important. So I mentioned here expensive, and expensive because it is truly expensive. A UAV here carried LiDAR, it can cost up to $200,000 and more. Therefore, higher the cost means that it is very risky to do the operation. No matter the weather condition or maybe the mechanical issue of the drone, when it fell from the sky, it can be a total loss. But for $500,000 or maybe more, because you need to add up with the cost of the UAV. So it is a high cost operation, but you can give a very decent result. As I said before, the LiDAR itself is sending out some signal and receiving back. It has a high detail, and on the other hand, it required a very top computing power. It means that you need to have a very powerful computer in order to generate such a decent result. and trainer and the operator need to be trained in order to read all the information. And since the laser, it has a range of accuracy. It means that it can't fly very high comparing with the optical sensor UAV. For in normal operation, it may fly, let's say, 50 meters above the ground, 80 meters above the ground, maybe at most 100 meters above the ground, because further away from the ground, the accuracy will reduce. Therefore, it is very useful for a relatively small area of scanning instead of a large area scanning. Okay, so in this slide, I want to show is a comparison and of the satellite image and also the UAV image of the same area. I borrowed the image from the internet. On the left-hand side, it is an image taken by the satellite. And on the right-hand side, it is an image generated by the UAV. So can you tell which one is with more details? So for the satellite image on the left-hand side, for every single image, it can cover a huge land area. We're talking about how in terms of square kilometers. So how it is highly depends on the orbit altitude. It means that how far the satellite is from its orbit to the ground. Some of the satellite, they are the low altitude satellite, and some are high altitude satellite. So with the high altitude, the resolution, or for every picture, the detail will be less. I think it is very much makes sense, isn't it? So for some commercial satellite, the resolution is ranging from about 30 meters to 50 centimeters. For 50 centimeters, we regard it as quite a good quality of the image. And of course, better the quality and more expensive. And I believe not everyone in the public can buy satellite image. Maybe it can, but this is not that easy to obtain. For the UAV image, also depends on how high you fly the UAV, but relatively it covers for every image, it covers for a smaller area, maybe in terms of the square meters. So, but because the UAV fly in a much lower altitude, so how the resolution and the details of the image is better. So it can up to 1 centimeter per pixel. This is a very high quality. And comparing with the optical sensor satellite images, the UAV image is less affected by the weather. It means that even though today is raining, or maybe even though today is a cloudy day, the UAV fly below the cloud, it can still take some pictures. And then, unlike the satellite, it may be brought from some high-level clouds. Therefore, it is less affected by the weather. And the image processing, and there is some image processing required, which I will talk about it in the later slides. And the training time is reasonable, and yes, you can have some decent image. From the previous slide, I talked quite a lot about the resolution, and we care about the resolution, but why? So for these 3 pictures, I think you can have a very good idea. For the left-hand side, this is an image with the resolution is 30 meter per pixel. And in the middle is much bigger. And for the right-hand side, this is 300 meter per pixel. So you can see which one is more is with more details. The higher resolution always means the higher cost and also more processing power. However, it is not necessary that we always trace for the best result. If you are looking for the area of the forest fire, so I believe the forest fire is not in terms of several tens of meters. It is in terms of several kilometers or even tens or maybe hundreds of kilometers. Therefore, a relatively lower resolution satellite image maybe is already good enough to take care of such a task. But for the urban planning or maybe some even more detailed surveillance mission, and a high resolution satellite image may be a good tool for us. Therefore, you always need to know what is your purpose and what you are looking for. Okay, so in the following slides, I'm going to show and share some case study that we have done by using the remote sensing images. In the part 2, I will talk about the environmental monitoring. So in the past few years, my center cooperated with some government parties in the northern part of Taiwan and in the New Taipei city. So they control of the reservoir in the northern part of Taiwan, and they want to make use of the remote sensing images to study the land change, to study the landslide, to study the green coverage. Is there any illegal building and maybe the road change? Therefore, they cooperate with us every year. We collect different type of images, the satellite images, the UAV images, to compare the past, current, and maybe forecast for the future. So here is some basic information of our project. The reservoir controlled area is around 330 square kilometer. How big is it? Anyway, it is very big. And our project is responsible to study for around 50 square kilometers, 48.7 square kilometers. So it is around 8,000 football court, if you want some idea. So it is very big as well. So we compare the satellite image and also the UAV image to do the analysis. Also in this project, we want to train if it is possible to analyze the image automatically using the artificial intelligence, and to compare the effectiveness of using satellite image and also using the UAV images. Okay, first of all, I want to talk about how the satellite image that we used. We used the SOS4 satellite images with the resolution around 1.5 meters. That means for each pixel, the length of each pixel is around 1.5 meters. So we compare the satellite image annually, starting from the year 2019 and onwards. So we compare different areas and see is there any land change. On the left-hand side of the slide, you can see some area that we circled with the red lines. So these are the areas that we suspect with the landslide occurred during the years. However, yes, we can see some bare land, but not quite obvious because of the relatively low resolution of the satellite images. So how about how the UAV images? Okay, first of all, if you have any idea how the UAV fly over an area, it takes a picture. As I mentioned, the area cover is not too big. It may be in terms of a couple of square meters. So how can this small picture combine together to be a big map? So here I want to give you some ideas. So when a UAV fly over an area at the same altitude, the same height, and also the same speed, it collects 1, 2, 3, 4, 5, and so on different pictures. So we combined it together and we call it the ortho photos. So here's a principle. So when the UAV, the drone, fly through an area with the fixed altitude and speed, it takes a picture constantly 1, 2, 3, 4, 5, so and so on. For every picture, it will overlap with maybe the second one overlap with the first one for a certain percentage. Normally here we overlap it for around 70%. The first one overlap with the second one overlap with the third one. Therefore, we can combine together to form a very big, decent map. Just like here, the first picture, second picture, third picture, and so on. We combined more than one picture and then to get it into to cover a large area. And of course, lower the UAV flight, it can take with more details and higher resolution. In the general UAV operation, the ground resolution can take up to 10 centimeters or even more. If you fly low enough, let's say 50 meters above the ground, the resolution can be very good. But of course, lower you fly, you need to take more time to cover the same area comparing with flying at a high altitude. In the past, it is very labor intensive. This is some picture that my colleague took in the past. Before the automatic flight, before the investment of the automatic flight, we need to take the picture to do the remote sensing manually, which means that I fly, let's say, the helicopter to take a picture, press the shutter one by one by one by one. You can see that the picture combined together in a very irregular manner, and also took a long time to combine the lens features to combine all the pictures manually. This is very labor intensive, and it always takes a long time, let's say in terms of days, in order to generate a map. And nowadays, thanks for the advance of the technology, it can be done automatically. However, even though the drone can fly high by itself automatically and take the pictures all by itself, we need to do a lot of planning, the flight planning, mission planning before the flight. And I will cover some of them in the later slides. Okay, so in this video, I just want to show you how automatically it is. So when the drone fly across over an area, so the picture take continuously one after the other one. So it can be combined by the lens features, and it generates a very beautiful map. So after we take all the pictures that we need, we can put it into some image processing software. Since today we are not going to cover a lot about how to process the picture, but I can tell you that around 80% of such process can be done automatically. We just need to select those useful image to take away some irrelevant image, and then the computer can take care of most of the work. The whole process can take, let's say, up to a couple of hours, depending how good the computer it is. And so the result, I can regard it as an instant result. For example, that something happened in the morning, we go and take pictures, and we can have the results in the afternoon. Everything is so much faster than in the past. So when we go back to our case in the reservoir, so here is the UAV image analysis. In overall, the resolution of our UAV image is around 14 centimeters, which is around 10 times higher the resolution of the satellite image. We took 3,122 pictures, and the image processing, it took us 2 days because it's so big. We did such process a year after the other one. So since the year 2019, we did such thing, and then we did it annually. And we compare the results of the UAV images and how does it look like. the result is fabulous. It's very obvious. First of all, we see two images on the top from the left-hand side and right-hand side. You can see here some vegetation recovery. It means that after maybe a landslide or maybe small-scale soil erosion, some vegetation maybe washed away or just by some kind of reason just disappeared from the area, and then they reappeared a year later. So you can see by using this UAV image, it is very clear to see that the vegetation recover after some time. So for the lower left and lower right image, we can see the slopeland engineering and recovering in progress. So some more green plants growing up from the slope structure, and we expect her to improve annually. Besides, we can make use of such picture to observe, okay, something happened. We can also quantify the amount. For example, to quantify the area of the land, how large is the landslide, and maybe to estimate when did it happen. So in this picture, you can see from the left-hand side, it is a UAV image. In the year 2021, 2022 is a satellite image, not too good. And for the right image is the year 2023. You can see some bare land. So we can make use of the software to circle it up the area and to estimate how large this affected area. So in this case, the bare land is around 0.112 hectare. It is not too big, but it is already an area to be concerned. And we estimate that it occurred around the year 2022 to year 2023. So by comparing the image history, you can see a lot of things. So we can see the UAV image gives us a very decent and some image with high details. But why there are some, I regard it as some disadvantage of UAV images over the satellite image in this case. First of all, the area is just way too large. I participated in this project and I need to go to the reservoir at least once a year, maybe sometimes twice, some 3 times a year. It's just too large to do that. Because the UAV need to fly at a very high altitude in order to take the picture, we flew around 800 meters above the ground level. So for every mission, for every takeoff and landing, the drone take around 60 pictures per mission. And then you still remember, for this project, we took 3,122 pictures. So you can imagine how much work it is. And because we fly high, it is so easy to be affected by the weather. There is a reservoir because that area is easy to rain and easy to collect water from nearby. Therefore, if we fly such high level, we are very easy to be blocked by the clouds. So our mission is simply difficult. It required a lot of careful and detailed mission planning, and it is labor intensive. I can tell it is very tired to do such project. And the photo processing took a long time. So in comparison, in this case, using the satellite image is more cost-effective than the UAV image. However, you can see because of the resolution, the result of the satellite image is not too good. So we fly the drone for around 1 week, so it affects by the wind speed, by the cloud seeding and rainfall, and so on. So if you want to have a good result, you need to pay a high cost. Therefore, it is always about a balance between the money, the cost itself, the time, so what are you going to study, and also how high accuracy you're looking for. Okay, so for the following session, I'm going to talk about some case study using the remote sensing image in the urban studies. There are lots of examples that we can cover, and I picked 8 of them to share with you. The first one is the urban planning, transportation, traffic management, disaster management, cultural heritage preservation, vegetation, green space planning, the heat island analysis, urban expansion and population dynamics, and also the establishment of the digital twins. I think need not to say is that remote sensing is take a key role in the urban planning. It can study the current situation and also predict for the future development. No matter by the use of the satellite image to take a large area observation, and use a UAV drone to take some very decent pictures. They collect the data and facilitate and also compare the land use of the map. The operator can also make use of some information and to find out some underutilized lands. Means that such area may be under development, and they can have a very better situation awareness. They can those information can guide the planner or those policy maker to give out a better strategic plan, or maybe to have a better decision. In the future, because they have such data, they can plan for their future. They can predict and analyze the urban trend and also to guide the future developments. The second one is a transportation. So transportation planning is essential for urban planning, and I think this is a common sense. So the remote sensing technology provides some real-time data. I think it's mainly talk about the satellite image, because satellite image is really instant picture to analyze the traffic patterns and optimize the traffic flow. It can reduce the congestion. And of course, if the policymaker, they can make use of that image to have a better planning of the transportation network, so how it can reduce the stress of the transportation, and also how to meet the growing demand of the urban population. Disaster management. Disaster management is one of the main focus of our center, the GIS Center in Fengjia University. In Taiwan, we face and encounter a lot of disasters. We have typhoons, we have earthquake, and subsequently it trigger the landslides. And whenever there's a landslide or flooding, the government has said they always want to know what exactly happened and how large it affected the population. So the remote sensing images is very useful and helpful for those policymakers, also those decision makers, to make up a plan to relieve and to help those residents. So in such case, the UAV imagery, it can provide almost real-time image. So for those of you who have some experience to fly the drones, so it has a camera. The most typical one is a optical visible light camera. So you fly the drone far away and you have a screen to see the instant image. You can take the picture to take the video. Those are the remote sensing imagery. So the drone can fly in a relatively low altitude and less affected by the weather, comparing with the satellite images. However, satellite image is a valuable resources in the aftermath planning, because it can overview the whole area in a very efficient way. So the policymaker can plan for the disaster response by using such satellite image. Okay, so we go to the cultural heritage preservation. Nowadays, we are now turning into a digital world. For some conservation person, they want to preserve some old building. Let's say those buildings for over 100 years or maybe even longer. Just in case if there's any accident, for example, a big fire to burn out the building, and they have a record, and they can use it as evidence to rebuild the building. So the remote sensing is a very useful tool in order to documenting and preserving the historical site. So how the size, the dimension, the color, the use of material can also be documented. So how the UAV image can create a digital record. We call it a blueprint or 3D models. I will talk about the 3D models in the later slides. And then it is very useful in order to restore this heritage. So in the picture here, you can see a lot of dogs. What does it mean? It is somehow for every dog is a picture taken by the UAV. So the UAV fly around the building. It takes a lot of pictures, and after some digital processing, and a 3D model can be generated just like this one. And I will give you an example in the part 4. Okay, so the next one is the vegetation and green space planning. And I believe the green space planning is one of the main focus. It's one of the main focus for the nowadays urban planning. And last month, I went to Melbourne and for a business trip, and I had the opportunity to visit the Royal Botanic Garden in Melbourne. And maybe some of you may have heard about it, is that Melbourne has a nickname, is called the City of Garden. It means that it has a lot of gardens inside the city. In the modern urban planning, and people are focused at putting more green plants around the area. So there are different reasons. For the physical reason is that the plants can absorb the carbon dioxide emitting maybe from the vehicles, from the factories, and of course it can generate and increase the water oxygen content in the area, which is physically good to our health. And in terms of mental, I think it is a very good idea to look at more green objects and to get close to the mother nature, and it can reduce the stress. And eventually it will improve our daily productivity. So the remote sensing can help us to assess the distribution of those green area, and it can for those urban planner, they can plan in which area maybe under utilized area can be planned as a garden, as a forest, and I think this is a huge benefit to those citizens. Okay, so for the next one is the heat island analysis. Have you heard about the heat island? In Taiwan, it is one of the hot topic for the urban planning. Heat island, it means that the urban area trapping more heat than the surrounding outlying areas. Those concrete buildings, the skyscrapers, the roads, and other infrastructure, they absorb a lot of heat during the daytime. And during the nighttime, they emit but trapped inside those urban areas. It means that if you use a thermal camera, you can see that those urban area is much hotter than some other outskirt area during the nighttime. So it means this is what the heat island means. So it becomes an island of heat, higher temperature. And when we use the thermal camera, we can detect it and analyze it very easily. So mapping using the thermal camera is quite similar with using the RGB, the visible light camera. And so what can we tell and what can we tell from the image itself? Okay, so for this image, actually I took it in Taichung City in year 2022 during the summertime. It's just like some puzzle, some Lego, but in fact, this is Taichung City. It's quite amazing. And so what can you tell from this image? You can see some different colors. Can you see my cursor here? You can see some darker color, like in dark purple, lighter purple. And you can see some brighter color, orange, yellow, and even I can see some red here. So for the darker color, it means a relatively low temperature here. So it is mainly some tree area. This is very likely is a park with some high tall trees. Therefore, the temperature is relatively low. And for some brighter purple color here, I believe this is some grassland. So it is not hard to tell that for the yellow and orange color here, it is the concrete road. And for some area here, I believe this is a car park. So by seeing the color pattern, and you can have some good assessment of the heat distribution. And you can see some interesting phenomenon here is that even though there are some buildings, but the buildings itself is not very hot. Some are very hot, but some are not. Because, okay, this one is the Taichung Theater. You can see even though it is a building, but why the temperature itself is not too high? Because there are some green vegetation. There are bright trees, some grass on top of the roof. That's why it can reduce the temperature of such area. So it is a very good application of vegetation into the urban planning. So in this picture, we can see the green area, green roof, tree lines. You can see even though some tree lines in between the concrete road to help you reduce the surrounding temperature and to make it more comfortable. Okay, so we have the thermal map of the city here, and we can further apply the 3D models onto the urban thermal map. What does it mean? So in some areas in Taichung City, here we have established some 3D models. We can put some those 3D models onto the thermal map, so it can show the effect of building density to the surrounding temperature. When we take a look of the picture on the right-hand side, you can see a lot of tall buildings here. So how does these tall buildings affect the temperature distribution? So is it affecting the wind carrying the heat away? So you can see some green area. The green, we got it as a green corridor. So how can this green corridor affect to the heat distribution? I believe this is a good effect to the heat island effect. So by applying the 3D models, we can have an even better understanding of how heat distribute and also how to improve the living standard of the citizens here. Okay. So for the urban expansion and population dynamics, it is very interesting that the remote sensing study is not only, I take a picture, okay, and that's it, I'm not going to do it anymore. So for the study, we can do it time over time over time over time. So we have the history. We know how does the area look like in the past, and so how what can we plan now, and what is the effect, and how can we improve better in the future. So the remote sensing is very important for the future planning and development. So we can compare different parameters over the time, and and it is very important and vital to allocate the resources and to manage the urban growth efficiently. Okay, the last one is that the remote sensing imagery is very important to establish the digital twins environment. Before I made the actually when I was making this slide, I considered quite a while should I open this topic, because digital twins is a very big topic indeed. If you are interested in the digital twins, you are more than welcome to search in the internet, or maybe we can talk about it through the email. It is a big topic, and it is a very hot topic nowadays. Generally speaking, digital twins is a virtual representation of something from the real-time situation. It just creates a mirror reflection. Just like on the right-hand side, we have a picture of a city. So we applied a lot of sensors in the city, like the temperature sensor, the wind speed, let's say the drill phone, the barometer, so on and so on, lots of sensors. So we collect all the sensors and applied those data into the models. So by seeing the model itself, you can know the real-time situation of the real world. So this is what we call the digital twins, just like a twin in the real world and the virtual world. But in the virtual world, you can see what's happening in the real world. So it can be displayed on a platform for visualization. And it is very interesting. And also, in order to establish the digital world, you need to have some up-to-date image. And where does those images come from? Is from the remote sensors. So it can be by the satellite image, or maybe somehow very pretty 3D models generated by the UAV images. Okay, so in the following slide, this is a part 3. I think I hope that my presentation is still interesting to you. And in the following slide, I'm talking something about the application for the policymakers. So I don't know whether you have any idea of what this picture here is capturing in this in these slides. So if you can read the Chinese, this is a disposal site. This is a recycling site in Taiwan, in Taichung. So in Taiwan, and when the building demolished or maybe locked down, and so the government will require, or maybe he need to get some waste handling free, because you cannot just dump the waste anywhere you like. You need to handle very properly. And therefore, some people, they just don't want to pay the fee, and when they lock down the building, and they dispose those waste to those waste area secretly. Therefore, the government want to use some new technology to analyze, okay, how much waste are there in the disposal site, and how much disposal are supposed to have in their record. They can compare the data and then to see if there is any person to dispose the waste illegally. Such waste may include some concrete, the steel bars, the bricks, and so on. So, but in this case, how can the remote sensor help? Okay, first of all, we need to turn the reality into the digital model. So can you see the difference? This one is a picture of the reality. We took the picture by the UAV. This is a with some tilt angle to see here. You can see some disposal area, and we generate a 3D model. It's pretty much like the reality, isn't it? Okay, some little theory behind. So what is the difference between the oral photo and the 3D model? So in the previously we talked about the 2D map. So one picture after the other one and after the other one. So how it grouped together to form a 2D map. This is what we call the oral photos. So 3D models is something different. So how it is a digitized model that can be viewed in 3D dimensions. It's just like I've got a water bottle here. So if I use it on a platform, I can see from different angles. Because it is a 3D model, you need to take pictures from five sides instead of one side only. I need to take from above, from the left, from the right, the front and back. Therefore, for the same area, if I want to generate a 3D model, I need to take pictures 5 times more. And of course, just like the 2D heat map, so lower you fly high your UAV, so you can get a higher resolution and a high accuracy, more detailed model. After we take the pictures, so we insert it into some photo processing software and then to establish the 3D model. So of course, more pictures you capture, more details you got, and you will have a better result. But of course, the processing time will take longer. From the left-hand side, left-hand side of the picture, you can see I use some pink color to circulate it, and we can select such area and to turn out to the 3D model that you can see on the right-hand side. So what can we do and what kind of results can we get through such a 3D model? Even though I'm not going to talk through it step by step, but basically we can measure the area and also the volume of such model with some specialized software. So in this case, the 3D model tells us that the area is around 1,000 square meter and the volume is around 920 cubic meters. So the government or maybe the authority can make use of such information and compare to the information on hand to see is there any other huge difference, any illegal disposal, and they can carry on their maybe prosecution or some administration. So this is how we can use the remote sensing images to help the policymakers. Okay, so for the following, I will demonstrate how can we use how can we use the remote sensing pictures to generate a 3D model, and how can we make it visualize? This is a very interesting project that took place like half a year ago. You can see a beautiful highway here. Beautiful highway. It is this is located in the middle part of Taiwan called Puli. It is number 6 of the highway. You can see the highway, some bridges here, and a tunnel link up to the other section of the tunnel on the other side of the mountain area. So we received a request from a government party asking us to make a 3D model of an area because they want to study how the landscape, how the huge mountain area affects their development in the future. They want to put this 3D model onto their platform, and then the user can see in different angles and to do some measurements. And so this is very interesting because if they want to do some measurement, means that we need to do it very precisely and with high accuracy, and we need to make a very beautiful model. So the project objective is to make the model to demonstrate on the platform and also some hillside studies. In order to prepare a successful mission, we need to do a lot of preparation. And so this is the only information that I got from from the third party. So when I asked them, okay, I can handle the project. Can you give me about the boundary? Where is it? How does it look like? And this is the only thing that we got. So I don't think it is good enough and informative enough to carry out the mission. So when I see the area, the first thing I would do is to understand where I'm going to fly and what kind of hazard or what kind of precautionary measures I need to do in order to have my mission successful. Therefore, I generate a KML. KML actually is a digital boundary of such area. And I want to display and show it to you with the Google Earth. Okay, so can you see the Google Earth here? Right. So I draw the boundary on the Earth, and I can see okay, it is like a hexagon area, and I can see what I'm going to face here. There are some highway and so on. But more importantly, I want to know the terrain and how does it look like. So it is very useful in the Google Map. So now I can see my computer is a little bit too slow here, but it doesn't matter.
Lawrence,
you can see
Lawrence, I think you can take
area here,
break.
And this is our boundary. So our boundary is the terrain difference of our area is huge. So it runs from the ground level and all the way up to the mountain. Okay, I want to try a little bit more.
Lawrence, you can take a probably 10 minutes break.
Oh, okay. Sure. So how about a 10 minutes break? Is it appropriate?
Sure, yes, please.
Okay, so thank you, Jay, for his suggestion.
Okay, we'll take a short 10 minutes break. So please come back at before 3:20 in Taiwan time. I think there will be some other places, but it's 3:20 in Taiwan time. There will be another probably 40 to 50 minutes lecture by Lawrence. Thank you.
Okay, hello everyone. So thank you very much, Jimmy, for his suggestion to take a break, because I really need to take a break to recover from my voice. I'm sorry again, Han, for my poor voice. Yes, because I'm still recovering from my flu. And so shall we continue our slides? Okay, so before our break, I mentioned that this is the area. This is this is the information that I got from my from the authority. So they want to take a 3D model in order to demonstrate onto their platform. So I make use of the Google Earth to study the terrain, and I noticed that the terrain is very steep, and there are lots of highways. So I realized that the highway is one of the risk. And also I need to plan for a suitable takeoff location. For some of you who, if you have the UAV operating experience, so how you may heard about how the airspace. So before I talk about how to take the picture, I think I should better to remind, if you want to learn how to create a 3D model or create some map, you need to fly UAV. First of all, you need to understand where you're flying. Are you flying legally? Because we have a lot of different airspace, and some areas are very close to some dangerous air zone. For example, the airport or military area. So these are very high hazard to the airplane nearby. So you need to check, and you need to understand where you are flying, and take some precautionary measures. And of course, you need to check the local regulations. I can give some examples in the Asia, Southeast Asia, and in let's say in Japan. And on the left-hand side, this is the map of Taiwan. You can see different colors. For the red one, it means that had a no-fly zone, means that no UAV can be take off and fly in the zone without permission. So for some yellow zones here, means that you can fly under some restrictions, some limitation. Let's say 60 meters above the ground, you can not fly higher than 60 meters. And even in Philippines, in Manila, they have some regulations. In Tokyo, in Osaka, they have even a very strict restriction. And what I want to say is that if you want to plan for a mission, and you need to know, you need to fly legally, safely, and also know the regulations. So in our previous UAV mission, so we need to, because we need to fly over the highways, which is controlled by the highway authority, we need to apply for the airspace restriction and application to the highway authorities, and we need to send an application to the Civil Aviation Authority as well. So remember, fly safely and fly legally. Some other preparations like the terrain. And so do you still remember in the previous slide I mentioned that nowadays the drone or the UAV, they can fly automatically. So in a regular pattern. But if the flight level or if the mission is safe, how high is it? It is a suitable altitude. Is that you need to study the terrain by studying the Google map, by studying some terrain map. So you need to study everything in before you plan for your automatic flight. And even though you can see, okay, it is just a flat land, but there may be some power line, some towers that is developing from the ground. So how close is it from the obstacles? And if those terrain, those obstacles are threatening and your control signal, this is something that you need to concern about. Okay, so come back to our mission. So as I mentioned previously, we need to do a very decent, detailed 3D model. That's why I took quite a lot of pictures in this mission. Do you still remember the terrain is just like a hillside from high elevation to low elevation? We need to take all the elevation and in different angles. Therefore, I took a lot of pictures from the high altitude from 300 meters, from above, on each side, and also from different sides. And also I had took some other pictures below 100 meters. For example, the tunnel here, some bridge, and we want to take the underneath area to have good details. So in this mission, we took around 800 pictures captured in five different flight levels and 7 different angles. So you can see in this video, okay, can you see some green dots here? So for every dot is a picture captured by the UAV drone. So from the very first beginning, we have some very high level photos to take this area of the mountain. The second high level to cover the whole area. And we have some more different layers. For this area, the lower altitude, and even lower, as I mentioned, is around 80 to 100 meters above the ground level. Also, besides different levels, we took pictures from different angles as well. So the bridge itself, the tunnel, the mountain is our area of interest. So we want to see all the legs of the bridge in good details. We want to see the tunnel and everything in good details. Therefore, we are not only taking from above, from the side, and also in a low altitude to point the camera towards the bridge to get high details. And you can see for the 800 photos, these are all the distributions, different levels, different angles to make a good 3D models. Okay, so this is the outcome, the final outcome of the model. Even though the area is not big, but we can see a lot of details here. You can see lamppost, somehow a billboard, the cell phone tower here, the line of the bridge very clearly, even though some area inside the tunnel. And here I want to show you is that for some diesel, from some very decent '3D model, I can even find a house inside the forest. So you can tell how powerful the UAV image can be done for the 3D modeling. To the government authority, they are very happy to see the outcome, and also they can make use of this 3D model because as I use my cursor to move around, they can also move around to do some measurements to see the slope land and everything around the bridge and tunnel area to do some planning. It is a very useful information, and also can be applied in the digital twins and digital city in the future. Okay, there are something that I want to mention to you. So if you are interested to do some UAV imagery survey in the future, just to be careful, be cautious. Not only the terrain, not only the airspace that I mentioned previously, but also the weather. Whether the weather is suitable for your operation. Is it raining and foggy? Because most of the UAV in the market, they are not waterproof. So the water may affect the picture quality. They may maybe even burn the UAV and then lost the control. So be remember to check the weather forecast before you go. And of course, the wind is very important as well. Now, as I had mentioned in the previous few slides, the wind speed, it may cause high wind speed may cause a high battery consumption. Means that the drone may not be able to stay in the air for such a long period of time. And also, is it safe to return? If you fly the UAV in a long distance, and is the battery good enough to return your UAV back to your takeoff point? So you need to have a lot of consideration before you take off. And for every time I do my mission, I always check the weather, not only in my local weather, but also the weather in general. So we need to see the weather forecast and also the current weather, and we need to have a good understanding about our UAV limitations. Okay, so I think here will be a good point to give a quiz to everyone, and I think you also need to complete a form in the website. So we have a QR code on the right-hand side. So please feel very free to scan the QR code, and then I think you need to complete all the information in the form in order to take the attendance. So we have covered the answer of these two quiz. So and also, if you have any questions, feel very free to leave me a mail here. So thank you so much, everyone, for your patience and listening to my lecture today. And if you have any question again, please feel so free to leave in the chat room, and we can talk about it. Thank you very much.
Many thanks to Professor Zhao for teaching and Professor Zhou for hosting. Thank you.
Thank you.
We end today's course. Please fill in the Google form and the 2-question quiz. If you have any questions, you can leave it in the Google form or email it to me. I will pass your question to Professor Zhao. Thank you very much for your participation. Next week is the final exam for the course. See you next week.